The appearance of Comet 3I/Atlas, also designated C/2025 N1 Atlas, triggered an unusually intense wave of public debate because it touched on a rare scientific phenomenon while colliding with long-standing cultural anxieties about the unknown. As only the third confirmed interstellar object ever detected passing through our solar system, it already occupied a special place in astronomy before any controversy began. Interstellar comets are fundamentally different from ordinary solar system comets because they are not gravitationally bound to the Sun. Instead of following elliptical orbits that repeat over thousands or millions of years, 3I/Atlas travels on a hyperbolic trajectory, meaning it arrived from outside the solar system at extreme speed and will eventually leave forever. This alone made it scientifically valuable, since it provides a rare physical sample of material formed around another star. However, the same rarity that excites scientists also makes such objects fertile ground for speculation, especially when their behavior is poorly understood by the general public. One major source of controversy was the comet's velocity and trajectory. Entering the solar system at roughly 68 kilometers per second, 3I/Atlas was moving far faster than typical long-period comets originating in the Oort cloud. To astronomers, this speed is a straightforward consequence of its interstellar origin. It was already traveling through the galaxy before encountering the Sun's gravity. To non-experts, however, such speed can appear suspicious, particularly when framed through social media narratives that suggest intentional motion or control. Hyperbolic trajectories, though mathematically precise and well understood, are often misinterpreted as course changes or maneuvers, especially when small deviations are detected in orbital calculations. In reality, these deviations are common in comets and are caused by non-gravitational forces, such as jets of gas released when ices heat up and sublimate. Another factor that fueled speculation was the comet's size and appearance. Estimates place its nucleus somewhere between 14 and 20 kilometers in diameter, comparable to a large metropolitan area. Its coma showed a reddish hue, which some commentators described as unnatural or engineered. In mainstream planetary science, however, reddish coloration in cometary dust is well known and typically associated with complex organic molecules called tholins. These compounds form when simple carbon-based molecules are exposed to radiation over long periods of time, especially in interstellar space. Far from being exotic or artificial, tholins are expected to be abundant in objects that have spent billions of years drifting between stars, exposed to cosmic rays and ultraviolet radiation. Claims of anomalous brightness changes further intensified the debate. Some observers noted that 3I/Atlas appeared slightly dimmer than early predictions, while at other times its brightness fluctuated more than expected. In popular discourse, these variations were framed as evidence of deliberate activity or even propulsion. Astronomers, by contrast, pointed out that comet brightness is notoriously difficult to predict, especially for interstellar objects whose composition and structure are not well constrained. As a comet approaches the Sun, different volatile materials sublimate at different temperatures, leading to unpredictable outgassing behavior. This can cause both temporary brightening and fading, as well as subtle changes in trajectory that must be corrected for in orbital models. The most persistent and emotionally charged claim was that the comet was deliberately hidden during its closest approach to the Sun. According to viral posts, 3I/Atlas supposedly disappeared at perihelion, leading to accusations of a cover-up by space agencies. In reality, this claim stems from a misunderstanding of basic observational geometry. The comet reached solar conjunction on October 21, 2025, when it appeared very close to the Sun in Earth's sky. At that time, its solar elongation dropped below about 10 degrees. Placing it deep within the Sun's glare and making it effectively unobservable from Earth-based telescopes. This is a routine and unavoidable limitation of astronomy, not an intentional blackout. Perihelion itself occurred later, on October 29th, at a distance of 1,356 astronomical units from the Sun, when the comet was already moving away from exact alignment and gradually becoming observable again. Despite claims to the contrary, 3I/Atlas was not completely hidden at perihelion. Observations with moderate equipment were possible at low solar elongation, particularly from equatorial regions shortly after sunset. By October 25th, the comet had clearly emerged from conjunction and was observable in the constellation Virgo, near familiar reference points such as Spica and Venus, at around magnitude 15. This level of brightness is faint but well within the reach of amateur astronomers using 6-inch or larger telescopes under good conditions. The narrative of total concealment ignores the difference between conjunction and perihelion and conflates temporary observational difficulty with deliberate secrecy. Independent observers played a significant role in both fueling and clarifying the controversy. Reports circulated from individuals and groups who claimed to have imaged the comet during the post-conjunction period, providing specific coordinates, magnitude estimates, and contextual star fields. These reports described images showing a distinct nucleus and coma, sometimes even within wide field frames that included the Sun at a safe angular separation. While such claims were sometimes presented as proof that authorities were lying, professional astronomers noted that these observations were entirely consistent with publicly available ephemerides, including data from NASA's JPL Horizon system. According to those calculations, the comet's position, distance, and brightness on October 25th matched the reported observations closely, leaving no discrepancy that would suggest manipulation or concealment. The involvement of high-profile figures, particularly Avi Loeb, added another layer of complexity. Loeb has argued that some interstellar objects, including the earlier visitor Oumuamua, could potentially be artificial in origin. While such hypotheses are framed as speculative and exploratory, they are often interpreted by the public as assertions rather than possibilities. This distinction becomes blurred on social media, where nuance is lost and speculation can quickly harden into perceived fact. In the case of 3I/Atlas, Loeb's openness to unconventional explanations was amplified by online communities predisposed to distrust official narratives, reinforcing the idea that mainstream astronomy was ignoring or suppressing evidence. From a scientific perspective, however, no peer-reviewed data support the claim that 3I/Atlas exhibited engineered behavior. All observed trajectory changes fall within the expected range produced by asymmetric outgassing. The slight discrepancy between predicted and observed brightness, such as a magnitude of 15.00 instead of an anticipated 14.76, is well within normal uncertainty for comet modeling. Interstellar comets, in particular, may behave differently from solar system comets because their surfaces have evolved under different radiation environments, potentially developing insulating crusts that delay or modulate sublimation. These effects complicate predictions but do not imply artificial control. Ultimately, the controversy surrounding 3I/Atlas says as much about human psychology and information ecosystems as it does about astronomy. Rare and poorly understood phenomena naturally attract speculation, and when combined with limited visibility, complex orbital mechanics, and the echo chamber effects of social media, even mundane explanations can seem suspicious. The idea that the comet might be something else reflects a broader cultural fascination with extraterrestrial intelligence and a growing mistrust of institutions rather than any concrete evidence. In contrast, the scientific interpretation of 3I/Atlas remains conservative and grounded in known physical processes. It is a fascinating visitor from another star system, carrying clues about planetary formation beyond our own. But so far it behaves exactly as a natural interstellar comet should.